It's 2 a.m. The deadline is approaching, and a stressed student is expanding a sparse outline into a completely AI-generated essay. While this happens every night, educators have a critical blind spot regarding how students actually navigate the ethical choices involved in using these tools. Traditional measurement tools struggle here, relying on Likert scale surveys that ask direct, obvious questions like, "Is cheating wrong?" or "Should AI be fair?" These surveys are vulnerable to social desirability bias, where respondents choose the answer they know is expected of them, rather than describing what they would actually do. These existing methods capture a student's general attitude toward ethics, but they stop short of measuring how that student handles an actual academic crisis. To bridge this gap, researchers developed i-SEMAI, an instrument specifically designed for the academic context of Malaysian matriculation students. This is a situational judgment test, or SJT, which replaces abstract statements with realistic academic dilemmas. By forcing a choice between different courses of action, the test observes the translation of ethical understanding into a practical decision. The conceptual foundation of the instrument is built upon maqasid al-syariah, represented here by two foundational blocks. The first block is ihsan, grounding technology use in responsibility, empathy, and excellence. The second is amana, which treats access to technology as a trust that requires honesty and the protection of rights. These principles are operationalized into 5 modern, measurable psychometric constructs. This integrated framework ensures that test scores reflect whether AI use is directed toward human welfare and preventing harm. Consider a scenario where a student uses AI to summarize a long reading, only to realize the AI hallucinated fake facts an hour before the deadline. The FAAST framework analyzes the student's next move. This begins with fairness, where 7 items evaluate whether the chosen response creates an unjust advantage over peers. The chart then shifts to accountability. Its 8 items measure whether the student accepts responsibility for the accuracy of the work or attempts to defer blame. Expanding to autonomy, 9 items measure if the student maintains critical thinking. Under safety, another 9 items assess steps taken to verify the AI's output. Finally, transparency uses 9 items to evaluate whether the student will declare the AI's role or pass the summary off as their own intellectual contribution. Every response option provided in these scenarios is designed to be highly plausible, which prevents students from simply guessing which answer looks the most ethical. This scatterplot visualizes the Rasch partial credit model, which processes these nuanced responses to map a student's specific level of ethical capability. The statistical model effectively weights the student's choices against the difficulty of the dilemma presented. By forcing these choices under pressure, the tool identifies how students prioritize these 5 conflicting values when there is no easy way out. i-SEMAI is designed to provide a diagnostic profile of a student body's ethical judgment, avoiding the simplistic labeling of individuals as ethical or unethical. The data from these 42 items helps institutions identify the exact areas where their students are most vulnerable. For example, if a student cohort scores low on transparency, educators can launch specific workshops on AI citation and disclosure instead of a generic lecture on academic honesty. These precise results can then guide the creation of institutional guidelines and orientation programs that speak to the actual challenges students face. As generative AI becomes a standard tool in education, these measurements provide the data necessary to ensure that student judgment remain at the center of the learning process.